Howdy once again, it's Mr. Pete, your YouTube shop teacher. And in this video I'm going to restore or rebuild or maybe just repaint this die filer. Now this is a POSTEL. I never heard of this. I found a few pictures on the internet, but I've never seen one before. They must not have made a whole lot of them. The motor is missing. This was a gift to me, 4 or 5 years ago from a man up in New Lenox, Illinois. And I just haven't done anything with it for two reasons. One, I was waiting to find a small electric motor, and I really never did, but I got one here that might do. And it does have issues. It doesn't turn over, so I'm not even sure what I have to do to it, but let's get started and see what I have to do on this. Perhaps you are not familiar with die filers, but it's just a little reciprocal machine that uses machine files. Now these are not regular files, and he did give me 3 files, and I'm sorry, but I forgot your name, whoever gave this to me, but thank you very much for it. And the file just goes up and down this little hole here, kind of like a jigsaw. And the filing is done on the down motion, not the up motion. I had one of these at the high school that I bought for the school. It was a FILER. I never did like it. First of all, it was very heavy, and it was a finger pincher, and it wasn't suitable for the kids to use because we did a lot of filing and hand work, but a bully would get a hold of it and use it the whole hour and not let anybody else, so it was just a nuisance. Also, the files were expensive and had to be ordered special and were easily broken, so it just wasn't suitable for a school shop at all. But it was used a lot by die makers. It would be great for a gunsmith, but the table tilts in 2 directions, 2 planes. So the first thing I'm going to do is to take the table off so you can see the mechanism a little better. From this direction you can see that the table can be tilted. And it's done with these thumb screws. There is no protractor. You would have to use a protractor to set it, or a gauge, from the table. Let's look at it from the other view. And from this view you can see that it tilts like this. So you can get a compound angle. Here's one of the adjusting screws. You're going to see a little bit better after I take the table off. Also notice that there's a pulley here. And I believe that it needs a larger one, and I think I've got a larger one so that it'll slow down a little bit. You don't want it to run too fast. The major issue with the machine seems to be that I'm not getting a full stroke. As I turn the pulley, it locks up. I'm not sure if this shaft is bent or the bearings are bad. This does not have an oil crankcase. It seemed to me that the FILER had an oil-filled crankcase, but I might be wrong on that. Also, I owned a Dual at one time that was in terrible shape, and I got rid of that in short order because it wasn't very useful. I don't remember much about it. So there are several brands besides the FILER. But I'm taking the table off now so that I can then get this out. But as I tried to remove the table, I realized that this shaft has to come out first. Now that I've got it apart, you can see that the mechanism is really quite simple. That block, I'm not sure what all these parts are called, just goes back and forth. There's an oiler, but of course you have to open this up to oil it. And these appear to be oil light bearings. Now I'm expecting, this will come right out as soon as I remove the pulley, that this might be bent, so I'm going to check that. But I took a piece of 1/2-inch rod and it slides very freely. I think it's a little bit undersized, but it slides very freely, so I don't see a problem offhand with these bearings. They might be worn. I'm going to measure them. But I put the shaft back in there without this block. It also slides quite freely. A little bit of slop here on the bottom bearing, so I don't know if the wear is in the shaft or the bearing or probably both. But I'm still not sure what the bind was, so I'm going to put it back together and see if I can get it to run freely. This thing is a bit of a jigsaw puzzle. One problem turns into another, but in order to get this, I'm going to call this the crankshaft because that's what it is. This bearing had worked its way up or was improperly installed or was installed after the crankshaft was put in. So I drove it down just a little bit, 1/8 of an inch, and so this one was down too far too. So now this will clear, but then I realized this shaft is so buggered up here that I'm going to have to deburr that with a file. But you know, this is a good example of why one needs a keyway and not just a flat, because the set screws have slipped over the years and just really galled and buggered up the shaft. So I'll clean that up and then the crankshaft will come out. Notice the oiler here. Gets. This was drier than a bone, so the shaft is pretty well worn. There is no bearing in here. That's strictly just cast iron, which is obviously sufficient for enough years. This apparently is a throwaway type of product anyway. Well, I'm going to pull these adjustments out and clean them up so that they will be a little freer, and then examine these bearings. But the bottom bearing looks pretty rough. There's a lot of marks on it, but these do not appear to be oil light bearings. They just appear to be bronze bearings. This has to be from the 30s. You know, I really don't think I want to make bearings. Maybe I can get them at Ace Hardware, but these bearings are 3/4, that's 750, and then I know they're 1/2 inch this way from measuring the shaft. So I dug out a bag of bronze bearings that I got a couple years ago. Do you remember in one of my videos I showed these that Tom Bellis from Arkansas sent me? More than this even, but looking through here, there's just all kinds of bronze and oil light bearings. Those are too big. But look at these. No way. No way. Where's my shaft? Did I lose that already? You know, these are long enough to where maybe if I cut it in half, I only need one. Of course, what am I saving them for? So I think I'll take those bearings out of there. I'll just drive them out because I'm not too worried about hurting them, but they could be drawn out with a threaded rod and washers and all of that, but that takes a lot of time. But I think I would not want to drive these in. I would want to draw them, or press them, I should say press them in, so that they do not get damaged or get oversized or anything like that. But I think this is going to be just the nuts. Here's the actual shaft. It's still a pretty good fit. So I think most of the wear is on the bearings rather than on the shaft. Now this shaft is pretty buggered up, but it's probably shrunk fit in there and looked like it's peened over. This whole machine looks relatively crude. That's simply a hardened dowel pin, but that's in good shape, I think. So that is the game plan. So I'll be back tomorrow or the next episode or in 1 minute or whatever after I get these parts cleaned up. But this is going to take, it's not real greasy, but there is some oil in there that needs to be cleaned up, and mainly sawdust. There's a lot of wood dust on there, but I think somebody had this in a wood shop, so. And I'd like to get this cleaned up. If I could fit this on the lathe, I would love to turn it down in a 4-jaw chuck, but all of this apparatus really prevents it from being held in a chuck without some kind of fixture or some kind of major effort. So I'll probably just dress it up. Wish I had a little sandblaster to clean that up, but wishing won't get it done. I'm back sooner than I expected, and I took this to the wire brush out in the garage, and the paint just about flew off. So somebody painted over paint over oil, I mean. Cleaned up pretty nice. Now, I will attempt to drive these bearings out. I turned down a bearing driver here. I'm going to set it on the floor where it's good and solid. And I just want to be very careful I don't break the casting. I said I was going to try to press them out, but then I'd have to come up with some rig that's more effort than this. So let's see how this works. I'm always shocked when something is easier than what I expect, but you can see what that bearing looks like on the inside. That's the bottom one. That one's not quite so bad. But putting these on the shaft, this is the original shaft, this bottom one is somewhat sloppy. I mean, it's not terrible, but it is sloppy. The new ones, of course, are a real nice fit. The old ones are 1 inch long. These are 1 3/4, so I will saw them off and then face them to length. They are marked Boston bronze. Nice looking bearings. Let's see if this one fits. Little tight spot. It would be nice if I had a line reamer to put through there, but I think, that's not bad. The stroke is right in here. It isn't a very long stroke either. So that's going to be just fine. I believe the next thing I need to do, and I've got these spaced out just so that this will fit in the crankshaft. Because, sometimes I forget the exact position. I didn't measure it, but I can go back into my own video for reference, so I found that handy. Sometimes I take a picture with my phone as I go along, but with filming it and doing the actual work, you know, and the phone ringing and somebody yelling at me, so, you know, I'm an old man, for crying out loud. Good morning again, it's Mr. Pete, and this is the next day, and this video is going to be far longer than what I thought. I'm trying not to include everything, and I'm skipping around on some things, but the first thing I'm going to do today is to put a keyway into the crankshaft, because the pulley, of course, is going to slip and go. Well, it already did. But this pulley that I'm going to use has a keyway in it, 3/16. Also, there were no center holes, so I already drilled this morning a center hole, and I'm going to drill another one here. I'll show just very briefly how I'm going to do that, because there's no good way to hold this in a 3-jaw chuck, as you can imagine, so I'll do it on the milling machine. And I'm only putting center holes in there so that I have a way of holding it so I can polish and clean the shaft. Really, the shaft should be replaced, but since it's shrunk fit in there, I'm just going to make do. Let's go over to the Bridgeport, shall we? Well, here's the setup, and this takes about 10 minutes to make the setup and find the true center of the shaft. Looking pretty good. You see, now I have a way of holding onto the darn thing. I wish they had put center holes in the shaft originally. Several hours have passed, and I've been working like a mad fiend, and I finally got it assembled, and it was a struggle, but now it's running quite free. But in a minute, I'm going to show you what the root problem, what the root cause was of the problem with this. Probably why somebody gave up on it years ago, but it's moving pretty freely now with the new bearings and some other touching up that I did. And on this side, you can see that I now have a key in place, so that'll get rid of that problem. So what I'm going to do now is take it apart and then prime it and paint it, and that will be done off camera, so you won't need to be bored with that. But after I get it apart, I want to show you what I did here as far as putting the table on, a modification that I made. Be right back. What the problem was, at some time someone had apparently hammered on this end, maybe to attempt to reassemble it. I'm sure it's been apart many times, but this shaft, the main shaft, was sticking out, not very far at all. You almost couldn't tell, but perhaps, and it's a press fit apparently, perhaps sticking out 5,000. So finally I realized that and was able to file that down smooth so that it's perfectly flush. That really was the problem. And yes, the shaft is a little bit mutilated, but it's going to be just fine the way it is. When I took this table off yesterday, it really was a problem getting it off of there. It was like a jigsaw puzzle. And the problem is that this stud here was a combination press fit, plus it was peened over a little bit so that it wouldn't pull through. So I'm going to discard that and use a bolt that will come in from the other side, so that, and this lock washer, the nylock washer, will be, or nut rather, will be on this side. Make it much easier. So I'm re-engineering a few things. I know it won't be authentic, but that will have to do. I did in fact clean up these adjustment screws, put them in evaporust, and faced off the end so they look a little bit better. So those are ready to go. So now I'm going to tackle this. There'll be quite a bit of wire brushing. I can't really take this yoke off, and that's no yoke, without great trouble. I don't want to hammer on things, and you know, if you break an ear off or something like that, you just got to throw it away. I'm not going to mess trying to weld it. I would throw the whole thing away and go upstairs and pout. So I will clean this, and then I'm going to paint the bottom of it, and then I hope to be able to do something with the top. I talked a little bit about that before. One can only wonder if my old Victrola 78 RPM will do any good at all to clean this up. Let's give it a try, shall we? I'll be back in 4 hours. Well, that was semi-effective, but the surface finish from the factory was very poor. So I'm going to degrease it, and I'm going to put it into evaporust overnight. Let's see what happens. There's still some rust on there. And this isn't really very critical. I would just like it to look a little prettier than what it does now. That's just about enough fun for today. I primed the main part along with the cover plate, so tomorrow will be the final coat, of gray of course. Well, that's the end of part 1 of this 2-part series on the die filer. There's still plenty to do in the second part as I paint and clean up these things, and then do the final assembly and testing, and perhaps even a demonstration. This is Mr. Pete saying so long for now, and I'll see you next time.